So, this is Computer Science 305, Programming Languages, and today we're going to be talking about regular expressions in Ruby. So regular expressions are simply a pattern matching capability inside of most languages. In my opinion, Ruby and others similar to it have probably one of the better approaches to handling it. So anyway, we're going to work with those today. So the first thing I'm going to do is I'm going to create a new file. We'll call it regex01.rb. And the first thing we're going to learn about is the very basic concepts surrounding regular expressions and pattern creation. So just like in most things in Ruby, we have multiple ways of figuring this out. And the first one, so we'll start with creating a pattern. So the first way, which is I would say the less than Ruby way, would be to use the actual regular expression object, which is regexp, and we'll call the constructor for that and give it a pattern. And so it's caret slash s star a dash z, and so what this basically says is I'm looking for starting from the very beginning of the string, and look for 0 more spaces followed by a character. So we can take this exact same regular expression here and construct it in two other ways. And the first is to, and then the most common way that we'll use is to use a pair of forward slashes or just slashes, and you put the regular expression inside there. And so that will create a regular expression for us to use. Another method is with a %r operator. So that would look something like this. So you %r and then you have curly braces, and you put the pattern inside of that. And so these are the three different ways we can actually create a pattern for us to use for matching. And so once we have that, though, then we actually need to be able to use it in matching. And so let's say we have a string. We'll call it name, and we'll give it the name of an artist, Fats Waller. And so now, if we want to actually match something, we can match it by, we'll start with puts, and we'll use the matching operator. The matching operator is an equal sign followed by a tilde, and then we give it a pattern. And so what this will return is essentially the index where the first thing matching that pattern actually exists. So if we're looking for inside this, and it should be known that if a character appears by itself, a character appearing, if it's not a special character, which we'll define what those are in a bit here, then it will attempt to match that exact character in the string. And so this would give us an index of 1, which is right here, which is the first occurrence of A inside the string. So if we were to run this, what we'll find, right, we say Ruby regex01.rb, and it returns 1 as expected, right? So we can continue this. So if we say puts, and we say, actually we'll use P for this. P is a shorthand for, I believe, print, and that actually for puts, and we say name match Z, and that should return nil. So if we run this, we should see nil, right? Which is to be expected because Z does not occur anywhere inside there. And now, if we were to say P A, and we take the pattern side, and we match that with name, well, it'll work for us, right? So it's bidirectional. If we run that, we see 1 again. All right. So now let's define a function to help us with a little more of this information. So let's define show, and I'm going to call it regex, and it takes in the first parameter A is the string that we are concerned with, and the second parameter RE is the pattern that we are going to be using for matching. So then we can say if A matches RE, and then our pattern, and if that's true, then what we'll do is we'll print out Alright, so now this is where it gets a little tricky. So when we go to match, there are these global variables that are created whenever you're doing a matching. And the first one is $backtick. The backtick is the key on your keyboard where the tilde is. So it's the key that you push to make a tilde without pushing shift. So the backtick will match everything before, will show us the part of the string before the match, and then we're going to put a double less than sign, and then we will look for the actual part that we did match, which is $ampersand. Alright, and then after that, everything that remains in the string, which is single quote, right? Okay, or $apostrophe, if you want to call it by that. And so else we will print out no match. Okay, so this is what we and then we'll end the method that we defined. So we can run this, and using very simple regular expression on the string very interesting, and we are looking for the match of t, right? So we run this, and assuming that we did everything right, we should see, yes, we surrounded the item T in interesting, the first T. So we'll run a couple more examples, right, on Fats Waller again. And we're looking at A, and just to verify that now this will find us the first A in Fats, just like it did before. And okay, so that looks good. So now if we do the same thing, except for now we're going to look for LL, right? So now we're looking for exactly two L's, one L following another. All right, we run that, and we're not going to run every single time, but we see that we get Fats Waller, and we found the double L in Waller. All right, and finally, if we run it one more time with Z, this time we should see no match, right? Because Z doesn't exist, and that was the else condition of our method. All right, everything looks good. So now we're going to copy this over. We're going to create another file, call it regex 02.rb, and we'll copy that in. And so now what we're going to look at is basic patterns, right? So this is, you know, we've kind of covered the basic concepts of regular expressions. So we'll call this. So now this is just a little bit more of the same that we just did. And so we want to say show regex, right? And we'll work with the string kangaroo. And now we want to look for a pattern. Like I said, anything that appears in here will match, unless there's special characters, will match exactly what we want. And so this should match the anger in kangaroo, right? So everything. So this section right here of anger in kangaroo. If we have, like, for example, in a regex, what if we had the exclamation point, at symbol, percent ampersand dash greater than equal to and plus, right? We want to match the percent ampersand. Well, that's pretty simple as well. Percent ampersand, and that's all good. And so if we run this, we would see that our expectations would be met. And look at that, it does. All right, found both the anger in kangaroo and the percent ampersand in that nasty collection of punctuation. Now, there are a set of special characters that we cannot directly match without escaping them. So the special characters are the period, the vertical bar, open and close parenthesis, open and close square brackets, open and close curly brace, the plus, the backslash, the caret symbol, and the $, star, and the question mark. In order to use these, right, if we want to use those, we have to escape them by using a backslash. So, for example, backslash or backslash pipe, right, for the vertical bar. So, for example, if we were to do this, we say show regex, and then let's say maybe we're looking at the string yes or no, right? So if we want to do that, we want to find the pipe in the middle. We need to create a pattern and then use the escaped version of the pipe, right? And this should return the pipe in yes or no. We'll run this, and then look at that, we did. Okay, so we continue this. Now a more interesting one would be if we wanted to find, say we have yes and then no in parentheses, right? And we want to find the entire thing of no in parentheses. So this would be the pattern slash backslash open parenthesis no backslash end parenthesis and then the end of the pattern, right? We can do the same, a similar thing too if we want to find a question mark, right? So let's say, are you sure? Question mark, and we want to look for E question mark. What that would give us is the pattern E and then backslash question mark, and so this should find everything that we're looking for. Alright, excellent, right? So we found everything we're looking for just like we expected. So now, what we can do is, for the next example, what we're going to look at is anchors. And so oftentimes, not only do we want to go and find things in the pattern, but maybe we want to ensure that the pattern itself that we're looking at meets a certain, as it meets a certain requirement. So the string that we're looking at in the position in the string, right? So let's create another example. We'll call this regex03, and we'll copy that fine piece of code over. So this is anchors, and what anchors are simply just pieces of pattern that tell us where in the string we want to look. So there are the first two are, now we're looking at, let's just look at a line in the string. So a string could be made up of multiple lines, where the lines are divided by slash ends, so new lines. So the caret operator matches or indicates that we are starting with the beginning of the line. And then contrary to that, we have the dollar, which matches the end of a line, and does not. And so we should note that there is also, when we end a pattern, right? So we have a pattern. If we end it with an M, that means we are including multiple lines, and so we're in multi-line mode, and this will slightly modify some of the things that we're talking about. But anyway, examples here would be show regex, and then let's say we have we're going to use this one string. So we'll say a equals this is slash n the time, right? So that's our string that we're working with, and so if we want to match for the at the beginning of a line, we use the pattern caret for, now we're saying start at the beginning of the line and the, right? So if we did that, we should have it return, mark the indication of the following a slash n. So we run this. This is 3, and as we expected, it matched the that we were looking for. If we did show regex on the same string, but now this time we want to match for the is at the end of the line, which is this is right here, is, right? We want it to say is and then dollar, right? And so if we were to run that, we see that it matched it exactly as expected. Now, much like we can match the beginning and end of a line, we can also match the beginning and end of the entire string. So /A will match the beginning of a string. So it doesn't matter if the string has multiple lines or not. It's the very beginning of the string. While we also have /Z or /Z, which matches the end of a string. Now, lowercase z matches everything including a /n, while capital Z, unless we're in multi-line mode, will match everything but the /n. So that's the caveat there. So we can say show regex, and then we say a, and we want to match for this, right, at the beginning of a string. So we say /a this, and that will match the this that we were expecting. Now on the other hand, we could say show regex a / and then capital A the. We won't find this because it doesn't exist, right? We have a the, but it's at the beginning of a new line, but not at the beginning of the string. So if we run this, we should see the this matched, but we get a no match for the second the. Now, all right. So finally, there's also what we call word boundaries. So pattern. So we have a /b, which matches the like a word boundary. So we can look for a pattern, and if we use the /b operator, it looks for the pattern only with word boundaries. So that's between. So we have spacing between. We can use spacing between words. We call those word boundaries, and so we'll only match actual words themselves. So and then so this matches with word boundaries. So what this is saying is, like, if I use /b before something, that means there must be a word boundary before the start of that pattern. And then if there's if I use /b after it, then that means there has to be a word boundary after that pattern. After that. So let's try this a couple of times. But before we do that, /B matches without word boundaries. All right. So let's say we have show regex, and we say we're going to match on /b is, right? So this is going to match an is with that begins with a word boundary. Okay. So if we and then we'll run another one, show regex, and a again, and this time we'll match with a /uppercase b is, right? And this will match an is without a word boundary, without using word boundaries, right? And so, if we were to run this, we would see that the first one of these last two matches this is, whereas the second one matches the is in the. So we run it, and we see what I just said comes true, right? Now, so now if we were to take this again and say regex, and we say a, and we say /is /b, right? This will match, just like the last one will match the is in this. Okay. Now, the interesting thing is, let's say we wanted to look for me, right? Me. If we said regex a, and we say the pattern is me/b, we'll hit the me in time. As expected. But if we were to look for me word, and we put word boundaries on both sides of it, which is essentially saying just look for the word, the entire word me, and that's it, we will find no match. Alright, so that's that's boundaries and anchors. So the next thing we're going to be looking at, and this is a really long example, is what we call character classes. Now this is how we define actual sections or special classes for different characters that we're looking for. And this is the beginning of constructing more important and larger pattern examples. So we'll call this regex04 RB, and what we want to do is we're going to copy that same piece of code over so we can actually keep running this. Actually, it might be easier. Here's what we're going to do, just to make it nice and easy. So, we created this a new file that includes the actual function that I've been copying over, just to stop having to copy it over, because that's annoying. So what we're going to do is we're going to require that inside of our new file that we're making. So we require regex.rb. So now we can have multiple files. Anyway, so now once we have that done, it makes it a little bit easier so we don't have to keep copying things over. And so basically this is this section is based on character classes. And what these allow us to do is set up specific definitions for things that we are looking for inside of a pattern. And so if we say show regex, and now a character class is defined by inside of our pattern we put a number of characters inside of square brackets, and this will match any one of the characters in brackets, right? And so that says, so like let's say we have a string A equal to price, which is $12 period. Okay. So let's say we want to find all the vowels in that. We can do that pretty easily by defining this to be the class that we're looking for to be in square brackets A-E-I-O-U, right? That's all the different vowels. Now if we were looking for that, we could also find and now let's say we there are some predefined ones. One of the predefined ones is for space. So this could be spaces, new lines, or carriage return, tab, etc. These types of characters. And there's a predefined one which is just /s. So inside of the character brackets, inside the square brackets, special characters like the vertical bar and $sign and all those things are not necessarily required to be escaped, but some are. That includes dash, square brackets for the most part, and then a few others are required to be still escaped if they're not the first character. So anyway, we'll come to that in a minute here. Another one that we can use is of the predefined ones would be for digits, right? Which is /d. So that will look for any digit that is 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And so if we were to run these, right, we would find that it finds I in price as expected, the space between price and the $sign, and then the first number 1 in the price $12. So that's pretty simple to do. We could also define classes for punctuation and a variety of other things. More importantly, though, we can also define a range. So now, if we have some character C1, let's say some character C and some character, let's say D, right, where these could be any character. If they can form a range, like for example A through Z, defines a range C through D, i.e. A-Z. That gives us a sequence of characters. Instead of having to write them all out, it just defines that for use, right? So it'd be any character from that range. We can see this, for example, if we were to say A is equal to C design patterns dash page 1, 2, 3. All right, so if we were to use this, we could say show regex and then A, and now we can look for all capital letters A through F, right? And that'd just be A-F. Okay, so now we're good to go. And this will find, as its first one, the capital letter D. And so we can say show regex again. Now we want to look for all the capital letters A through F and all the lowercase letters A through F as well. Well, that would be A dash, capital A dash, capital F, little a, little dash, little f as our pattern. And so that will find the first E in C. And if we want to look for the number, right? So we could use the /D, or we could actually define it. And so /D will give me all the numbers 0 through 9, but what if we were looking for the first number 2 through 6, right? So 2-6, which will find the 2 in 123. And then we want to look up, maybe we want to find 2 digits next to each other that are, for example, between 0 and 5. And so that would be 0-5, 0-5, and then right next to it would be again 0-5. And so if we have that, then we can run this and we can actually see that these patterns work as we expect them to. And for the first one we found, like I said, the capital D, and then we found the first E and C, and then we found the 2 and then 1, 2, right? Alright, so that worked as expected. Now, sometimes it's actually easier to describe the character class that we're looking for by describing what is not in the class. And so in other words, we want to negate. And so if you use as the first character in your class the caret, what it will give us is the capability to negate of that class. So for example, if we wanted to find any characters that are not vowels, right, then we can say A, E, I, O, U, and so this would be the non-vowel class. Unfortunately though, it finds all characters that are not vowels in this case, but the caret, we'll say caret ... negates, returns the negative, or matches, let's say matches the negative of the class. Alright, so if we were to use this, we can find things, also we do need to note that you can use, if you want to match square brackets or a dash, right, because obviously that's what we have, they need to be the first, they must occur at the start of the class. Otherwise, they must be escaped using the backslash. So let's say we say show regex So if we're looking for the regex, and then we say A, and we want to find a square bracket, right? The beginning square, the ending square bracket, and so that will find the very last thing after the number. So we show regex and then A, and we want to look for a dash, the dash between patterns and page. So we can do it that way. And then finally, the last two will be negating. So maybe we want to say show regex. We want to look for anything that's not a character between A and lowercase a and z. So we can negate that by saying A-Z. And maybe we want to find one other class, A, where it's anything that's not lowercase a through z or a space character. So not A-Z or /S. So what this will do, the first one will, as we already said, the first two find exactly what we're looking for. The rest will find the first one here, we'll find the space between C and the bracket. And the next one, we'll find the actual opening bracket. So we'll run that and validate. And like I said, we found originally the ending square bracket, and then we found the dash between patterns and page, and then we found the space between C and the opening bracket, and then we found the opening bracket. So that's pretty simplistic stuff. And we've already talked about the special classes. There's several other ones. So there's many other special classes, including that are basically what these are. These abbreviations are simply classes that are used so often that we just came up with them. So you have, for example, /s for space characters, and then /S is non-space characters. And then you have /W, which are word characters, and it's basically the class 0-9, A-Z, A-Z, and the underscore character. And then you have /W, which is non-word characters. And then we have /D is digits, so 0-9. And then /D are non-digits. Alright, so we can easily use this. For example, if we were to go back to, if we were to create a new string, it costs $12, right? And then say show regex, and then A, and then /S. And then we do another one, which is show regex A and /D. Oh, maybe we'll do one more. A and we'll say /W. Alright, this first one finds the first space between it and costs. The second one finds the first number, which is 1 and 12. And the third one will find it, right? It's the first word. Actually, it'll find I. So we'll enjoy that. So what this will do, if we run it, we come up with those exact answers that we just talked about. And so now we've seen, with all this, the basic constructions that we need to be able to start putting things together. But unfortunately, it would be a real pain if we had to continually, to make one pattern, had to put all these together. For example, if I needed to match three digits in a row, if I had to write, you know, a /D/D/D each time. Well, that's just, and you know, if we have really complicated patterns, that would be very, very troublesome and very difficult. So instead, what we have come up with are descriptors that tell us for repetition and alternation, right? And so we'll create a new file and we'll cover this. So regex 05.rb. And so basically this is replication, but first we're going to require alright, got past that. That gives us the code that we were just working with. So repetition and alternation. So what this gives us the capability is, the first thing we have to talk about is what is repetition. So there's all these different operators that we can use. And these are the ones that we've been talking about for the most part, excluding the square brackets and the pipe. And so let's say we have some pattern, right? And we want to replicate it. So we can use replication in our patterns. And the first and so the first one is, let's say we have some pattern R, right? And we can say R star. And what this implies is that we are search for or sorry, let's say matches 0 or more occurrences of R. And what if we have the next one would be if we have same pattern but R plus this time. This matches one or more occurrences of R. Now if we have a question mark, this is saying matches at least 0 or 1 occurrences of R, right? So this is basically saying R is optional. Now we can also have a specific number of matches that we want to make. So if we put in curly braces after R, our pattern M, comma N, then we can say that it matches at least M and at most N occurrences of R. And if we say R just M comma, that says matches at least M occurrences of R, but it's unbounded on the maximum. Finally, we can say R and just in curly braces M, and this says matches exactly M occurrences. Occurrences of R. And so we can take a look at this. Like, let's say we have a string A equals the moon is made of cheese. Okay, so if that's the case, we say show regex A, and we want to find the first occurrence of one or more word characters. All right, so we would expect to see that it will find at least T in the, right? Well, what this will find, in fact, is the entire word the. So there's an issue with this. In most instances, the regular expression processing algorithm is a greedy algorithm, meaning that it will try to find the largest number of repetitions of a given pattern that you're looking for. So that's why we found the entire word the, but it stopped as soon as we stopped matching the pattern. So the first occurrence is THE, and then there was a space. That's a non-word character. So if we look for example, we want to find a position where something starts with an S, a space, and then any character, and then ends with a space. And so we can do that by seeing that we say /s dot star /s. And so what that says is find a space, and then the period matches any character, so 0 more of those, and then a space, right? Well, the problem here is, and so what that's going to do is it's going to try to find the largest match possible. So we run that, it will actually find the space before moon all the way up to the space after of. That might be too large, right? So maybe we need to restrict this to only. So we say show regex. We only want to find the first word that has a /s, some characters in a /s, right? So we redefine this to be dot star question mark, and what that's going to do is we're having at most one of this whole portion of the pattern up until we hit this last space. So if we were to run this, we see that it will find only moon this time. Now there are times when if we want to, we can say show regex, and then now we want to find, for example, let's say we want to find at least 2 but no more than 99 possible vowels, right? So we say, we have to go through our A-E-I-O-U for our class, right? And now we're going to use it for this class, in curly braces, we say at least 2 vowels, but no more than 99. We could just say exactly 2. Let's do that. That might work out better. And so we should find out this would match. Well, we have 2 options, and it's either the double O in moon or the EE in cheese. But since it will find the first one, it will give us the double O in moon. And then furthermore, we can say show regex, and then we let's say we want to look up MO and then question mark O, right? So now we could think that this might only find the first MO, but since it is, it'll match the largest version of the pattern that it will find the moo part of moon. So we go ahead and run this, and we can see that all that is working as expected. Alright, now, so that's repetition in its most basic form. The next thing is alternation, right? And so if we want to provide the capability to find alternates, right? We have potentially two different things we want to match. Then we can easily construct that using the vertical bar, right? So vertical bar provides for alternatives. And so let's say we have the word the sentence, we'll say phrase, red ball, blue sky. Right, so we say show regex A, and then we want to find either an E or a D, right? And so that gives us a pretty simplistic capability, and the first thing it will match will be the E in red. If we were to go and try another one, we say A, and then we want to find either AL or LU. So this will find literally the first two characters, AL, or it will find the characters LU, but it's not A, L, or L and U. All right, it's one of those two, but not a portion of the two. So that will give us, and then finally we'll do a couple more. Show regex A, and then red ball or angry sky. And so since we only have red ball, we don't have angry sky. And bear in mind that the space here is just a character. It's not some sort of spacing for grouping. It will find the phrase red ball or the phrase angry sky. So if we go ahead and run that, we see it finds the E in red, the AL in ball, and red ball in red ball blue sky. So interesting enough, we can start the next section we start talking about. So now I was kind of alluding to it, is that there is a potential for possible grouping of things, to which we can then apply all these replication operators as well as alternation inside of it. So grouping is pretty simplistic and easy to understand. It's just an extension of what we already have learned. So we'll go ahead and require. So we have our nice little show regex method. So the first thing we want to do is, let's say, so for groupings, right? Grouping is just provided by using the parentheses. And so now each group is basically its own internal small regular expression. And so we can say show regex on banana. And then if we want to find, so we could think that we say A N star, right? Well, that will find 0 or more AN. Actually, it would find A and then 0 more N's, but it won't find 0 or more ANs. So we said show regex, and then we say banana, right? And we think, oh, we can be clever, we'll use grouping. So we say AN star. So we expect that this second one will find AN in banana. But what we'll find is that's not true. And I'll explain why in a second here. Instead, what we'll need to do is to use AN in parentheses, but have plus operator after it. So the problem here is AN in parentheses star actually matches nothing as easily as it does something. But since there's nothing else here before or after this pattern, this group, it will match the closest thing, which will be nothing. And so when we run this, we'll see that. It's not, oh, sorry, I'm looking at the wrong one. It doesn't, it's not that it doesn't match anything, it matches the spacing right before the word starts. So it does match the fact that the empty character right there. The second one matches as we wanted it to, the AN in banana. Now let's say we have another example where we have where we want to say show regex, and let's say we have right. So Python's a language. We want to match. We want to see if this actually matches let's see. Let's say, oh, actually, you know what? We can, let's try it like this. Yeah, that'll be fine. P, and then Earl or Ithon, right? So this would match as long as it's either Perl or it's Python, right? So we can see that for sure. If we run it, it should come out as it matches, right? So it found Python. Okay. So alright, so let's say we want to try a little bit more of this grouping action. We say red ball, blue sky again. So show regex, and then we want to find blue or red as before, and that should find us in the red ball, blue sky. Will find red. If we were to try it with show regex, now we want to find that within the group blue or red, followed by a space, and then one or more word characters. So let's see if that works. So that the second one should find red ball. The first one finds red. So we run that, and we see that will work. Now, if we were to run this again, so we say show regex a. We need to note that it doesn't matter. The order of the alternatives does not matter here. This goes with whatever it can find first. So we say red, blue, and then W plus, right? It will still find the exact same thing, but this time, finally, if we say show regex a slash red or blue slash W plus, now we find only red, right? It's either red or blue followed by a space and one or more word characters. So if we were to run that, we can see that's for sure. And it finds the last one finds red. The middle two, the last two. And the middle two of the last four that we did finds red ball. All right. Now, on the other hand, if we were to say show regex a and then red ball, red, and then in parentheses a group ball or angry, and then sky. Well, this will end up finding no match, right? Because there's nothing that is red, then either ball or angry, and then sky. But if we were to change it to be the red angry sky, right? Then we say show regex. Actually, the same thing as this one. What we'll find is that it will find the red angry sky. And as expected, right? No match, then it found red angry sky. So that's all good. And so the next thing we really want to do is, why did we do this? So yes, we can match and we can find things, but what are we going to be able to do with it? Well, now we need to be able to actually get in there and do some substitution or something like that within the string. And so that's the next part of this this whole business. So the next to last example. Oh, wait, that's not what I want. All right, so we require Okay. So let's say we have a string. Actually, we don't need to require that. We're not using that this time. So we have a string a equals the quick brown fox. Okay. So we take this, and the first thing we have to know is that string has a method called sub, right? And sub allows us to do substitutions. There's various different forms of this. The main one would be it takes in a pattern. So let's say A, E, I, O, U, right? We want to look for all the vowels. And then the second part is what we're going to substitute it with. Now this can be either another string, or it could be a block. And we'll talk about the block one in a second here. But if we were to run that, this will... this first one here will substitute a star in for E and the. Now, that's all great and everything, except for we'd have to run this a whole bunch of times until there was no changes left in the vowels, or in other words, until we didn't find a vowel. Well, that's very annoying, and we shouldn't have to do that. Instead, what we should do is we can use a global sub, so G sub, and if we do the same thing, A, E, I, O, U, we would see that, and we put star, this will actually replace all of them at the same time. So if we go ahead and run this, we'll see that actually works out. I need to print. So now we can actually see this. Alright, so like I said, the first one return only changes the E and the, while the second one replaces all the vowels with stars. That's using G sub. Now the problem here is that if I print out A again, we will see that I did not actually change the underlying string. But if we wanted to, if we chose to instead, after either sub or G sub, use the exclamation point, methods that have an exclamation point tell us that they actually modify the object on which they're called, and so this will actually change the underlying string. So we run it again after I save it. We'll see that the string did in fact change, which is probably not what we want, but in this case. Anyway, so if we were to then, maybe we want to run and find all these spaces. So let's say we have a pattern where we say we want to find space character followed by a non-space, one or more non-space characters, which would be all words except for the. And then we want to replace that with an empty string. So this first one will return the brown fox if we print it. Right. The second one, this next one, if we did it with the G sub, will then return just the. So we run that, right? We can see that this comes out, right? We have the brown fox and then just the. So that's great. That's nice. We now know how to substitute things using regular expressions. So if we can find it, we can replace it. The next thing we want to do is maybe we have other things that we want to do besides simply replacing. Maybe what we want to do is make extra modifications. So for example, instead of replacing, we actually want to give it a block of code that we're going to use for managing that. So let's say we want to find the beginning of the line, right? The first character at the beginning of the line. And what we want to do with that is we want to change its case, right? Capitalize it. And so when we use a block, we're given a variable, and this variable is the first. In this case, it's the match that's found, right? And so what we're going to do is we'll say, in this case, it'd be the first match that's found, the first word, the. And so then we just say matched uppercase, which capitalizes that letter. And so this will capitalize the T in the. So if we run it, we can see that that's true. And look, it uppercased the T in the. So again, if we use G sub instead, so this is going to essentially for whatever we're looking for, cause it to run this as a loop across every single one of the individual matches. In this case, we'll look for any vowels, A, E, I, O, U, and we're going to upcase them just like we did before, but this time we'll say vowel as our variable, and we say vowel.upcase. So this should take the E, U, I, O, and both O's and uppercase them. So we go ahead and run that, and it did exactly as I said it would. So that's great. That's very good. Now, a slightly more involved version of this could be defining a method, mixed case, and the goal of this method is to capitalize each individual word. For example, if we were looking at a name of a person, right, we want to capitalize each individual part of their name. And so what we want to do is say name.gsub, and so we're going to work with a word boundary. So as long as the word has a boundary on it, we can then and is followed by, it's a word character, right? It's a boundary followed by a word character. We can then assume that that's the first character in the word, and so we just say first.upcase, right? All right. So let me end that. Now we can then say mixed case, and we can look at maybe a couple artists, like for example our Fats Waller from before, and then like maybe say Louis Armstrong, and maybe we'll capitalize just a sentence. Maybe it's like a title of a song or something like that, and we say strength in numbers. And maybe we want to print these just to validate. Alright, so we go ahead and run this, and it does exactly what we want. It uppercases each individual word from within the text provided. So that's awesome. Alright, now we're going to go through a even more involved two examples. The first one comes from the HTML processing API from Ruby itself, and so we'll call this regex 08. And so this one's a little bit more difficult. So let's say we have a string of HTML text, and so in HTML it's kind of nasty if we want to write certain symbols that are a part of the language itself. So for example, quotes are part of the language, less than, greater than signs, and ampersands, and a few other things are all part of the language itself. And so in order to write them, you end up having to escape them. And so oftentimes if we want to display what that text actually looks like, or to see understand it, we have to unescape it from its HTML form. For example, if we wrote a tool that scraped the web, we have to unescape the text in order to make it useful for humans to look at. And so, for example, we can have the string 1 ampersand LT semicolon 2, let's say ampersand amp colon ampersand amp semicolon space 4 ampersand GT semicolon 3, right? That string is actually the equivalent of 1 is less than 2, double, and 4 is greater than 3. So that's what it's supposed to look like, but this is what we're given. So maybe what we do is we'll put that in parentheses, and we'll create a method that we'll call unescape HTML, right? So that's what we want to do. We want to unescape this. Another example could be the string end quote semicolon a end quote semicolon. So those are this is saying a in quotations is equal, and then we put an equal sign, and then end hash 65. So that's the number 65 is equal to and hash x. This is the hexadecimal number 41. Okay. So we put that in parentheses, and then say puts unescape HTML. So now we need to define this method. So we say def unescape HTML, and it takes in some string, right? Maybe we call that unescaped. Okay. So now, first thing we have is we need to duplicate the string, right? So we need to make a copy, a shallow copy of the string, because we're going to do some modifications. So we say string.dupe. And that gives us this, so now we can modify the string in place without having to worry about modifying the original string. And so then we say str.gsub. So the first thing we need to look for is whether or not it has the only thing that we're trying to replace are things that start with an ampersand and end with a semicolon. So the pattern that we're looking for begins with the ampersand, and then can be any at least one, if not more than one, any character, right? So we're only looking for one section, one instance, full instance of this group where we have any character. So now that we have that, and then it ends in a semicolon, and so that's the pattern we're looking at. Okay, so we give it a block. In this block, we create a new string called match, which we then can use $1. Now, $1 is a global variable that is holding the contents of the match found in this first group, right? So all the groups that we create, where groups are defined by the parentheses. For any group, they're all numbered, starting from left to right, and we can use this to give us the capability to again match on that, right? Because each group is considered its own internal regular expression, so then we can manage to deal with this. So we say $dupe, and then with match, we're going to run a case on this, because we have several different things we're looking at. So for each case, we're going to conduct another match, right, to see if it matches something. So we're going to start at the beginning of the string that we're looking at for match. And so we say, and then we want to find out, is it amp, right? And then does the string begin with, starting at the beginning of the string and going to the end, does its contents contain amp? And furthermore, we're going to modify this to be case insensitive. And so we're going to put a lowercase I there. If this is the case, then what we want to return is the actual ampersand symbol. So we do this again, so /a, and then we're looking at quote, /z, I, and then we say then we want to return a single double quote. In the case that it starts with, so it's GT, then we want to return the greater than, the greater than symbol, and we do the same thing for LT. And then now it gets a little more difficult for the numbered ones. So what this is actually going to do is we're going to return the ASCII value of that. We have to first look for the hash symbol, and then we have a character class which is D, right? We're looking for any decimal digit, and we want at least one or more, and then it we don't need to care about whether or not it's upper or lowercase, because we're assuming we're looking for a number. And then for that, for the first one we found, the first match that the inner grouping there, so $1 again, and we're looking at the character class for that. So I have to actually validate what I'm doing. Oh, then, right? And then we also do this for the other one, which was A, and then it was the hash and X. And it was now this one is slightly different, right? Because it's a possibility of multiple things, because it's hexadecimal. So we can have 0 through 9 or A through F, and one or more of those. And then we are concerned with it being whether or not it's a possible upper or lowercase, because oftentimes people write uppercase letters or lowercase letters, but not sure which one. So then we look at, again, the $1, and then we look at the hex value for it, and then the character of that. So this is all of our cases that we're concerned with. And then once we're done with that, we return the string representation that we found, so the modified string. So if we run this, we should be able to see that in fact it does return the expected strings. And lo and behold, it did. So what we get to see is, oh, actually we mistakenly did that, so let's just fix that to make sure it's right. And it is. Okay. So now, one last slightly more difficult example would be checking for email. So let's say you're writing a web app, and a part of that would be you have to validate someone's actual email address. So that's a very common thing to do, validating emails. So now, the first thing we do know is that, let's say we have an email address like Isaac at say sparkline.com. Okay, so we know that this is a valid email, right? It meets the condition that I have to have something that is some sort of characters prior to an ampersand at symbol, and then we have to have characters following that, and then there needs to be a dot, and then some characters following that. Okay. So let's create a constant, valid email regex. And so when we were creating these things, we need to realize that no one just creates a regular expression, out of thin air that's very complicated. We start out breaking it down into the pieces that we can easily work with, and so we start from the large and work down into small sections until we've developed the entire regular expression. So this starts out, so we have our pattern, and I probably need to make sure that this is named correctly. So let's rename that. Okay, much better. Okay, so first things we know is we want to start at the beginning of the word, of the string. So let's start with that, and we end at the end of the string. Okay, that's good news. And then we know two things. One, the things that are not going to change is we need an @ symbol, and before the end of it we need a dot, right? So those are the beginning pieces, and we're getting very close. Do you need to get rid of this? Should be a \Z. Okay, so now we're there. So those are the two things we actually know. Now we said that it needs to have at least one character. We'll say it needs to be alphanumeric character following the dot symbol. So let's make that class A-Z, and we need one or more of those. So that solves that one. And let's assume that we want to be case insensitive. So now we've met that part. We also know that we need to have something preceding the dot and after the @ symbol. And so this could be anything between that could be alphabetical. It could be a digit, and it could possibly be the dash symbol, so a /dash. So but then we could have, we can have one or more of those, but we can also have an extra case where we have another dot in there. So we have another class that has a dot, and then we could have A through Z, and we can have one or more of those. So let's just allow that to occur, and we can have 0 or more of that class. So this is essentially saying we can have a dot, so we can have it's like a URL, right? For example, my email address for the school is isaac.griffith@msu.montana.edu. So this is capturing this section, right? So if we just left it being the first part, which was a series of alphanumeric characters in the dash symbol, and we had one or more of those, that would not capture this second one here. So that's why we had to add in that extra piece. So now that we have that, so we've accomplished anything that was valid from the @ symbol to the end of the actual string. So now we need to capture the first part, right? And so now we have this capability. We know that first off we need any word symbol plus and a dash, right? Okay, so we know that, and we need to, and then possibly a dot, right? So one dot, one or more dots, one or zero dots. So basically, what this is saying is any word character, a plus or a dash, and followed by a dot, zero or more dots, 0 or 1 dots, and we can do this one or more times, right? So that's what we are claiming we want. And so this is our basic email string. So I'll break that down into its, let's break that down one more time just to be sure we're clear. So the /a is start of string, right? And then we have our /z, which is end of string. Alright, so we've matched those. And then our first one was /w plus, we'll just put that, we have /w plus /dash and then a dot question mark, right? And we put that whole thing, this is the first part of the pattern. And so this is 1, so 0, oh sorry, that's a plus, yep, that makes sense. So this would be one or more word characters, one or more word plus dash or dot characters followed by a dot. Alright, so one or more word or any of those characters followed by a dot, and then the let's see, it's the @ symbol, and then it's A through Z. So this is the first part is A dash Z slash D slash dash. So and then plus. So it's one or more alpha numeric and or the dash characters, right? Which is then followed by the grouping, which is a /dot, then alphabetical plus, right? So then it's and then star. So this becomes 0 or more, and then in group the group a dot followed by one or more A through Z characters. Okay, and then finally, right, then the dot character, dot, and then one or more A through Z characters. And that's the whole thing. And then it's case insensitive. Alright, so that's the breakdown. Now, we just need to use it. So we define a method. So is valid email. It's a Boolean method, so we end it with a question mark. Takes in a one parameter email. And then we want to say email, and then we're going to match it. Match it on our valid email regex, right? And then we end that function. So now we actually have to test it. So we expect, if we say puts is valid email, right, on this, that this should return valid. So we want, for any time we make this call, we're either going to print valid or invalid. So if it's true, if it returns true, it prints valid, otherwise it prints invalid. So we know that this one, both the first two should be valid, right? Puts is valid email. So let's add an invalid one. And we'll say Isaac sparkline.com, right? So we're missing the @ symbol. So this should come out as invalid. And then let's do a couple more. So we had the dot one in the front part, and so let's maybe put is valid email, say Isaac G at sparkline.com. So it should be able to capture the concept that there's an underscore. And finally, let's say, and we captured the, there's a dot, and now we need one more invalid one. So let's verify. So Isaac G at sparkline. So no extra .com there. So it's missing that last part. So then we ask, is it valid or invalid? And this one should also be invalid, right? We also do that here, valid or invalid. And so what this is going to say is we should see valid, valid, invalid, valid, invalid. That's the expected results. Let's validate 9. And we see valid, valid, invalid, valid, invalid. Exactly as we expected. So this last example wraps up the basic regular expression experience. For part of your lab, for the Ruby lab, you'll be using a whole bunch of this. If you can understand what we did here and what we're going to do in the class, then you should be pretty good to go on regular expressions. At least that will suffice for this specific class. If you need any more help with that, please consult. There's a whole bunch of places that you can look this stuff up in, including but not limited to, for example, Programming Ruby, the internet, and 1,000 other places. I look forward to hearing your questions on this. Please email me if you have any, or ask in class as I'm walking around. All right, thanks a lot. Have a great day.